Welcome back, everyone, for another deep dive. This time, we're going to be taking a look at something pretty interesting.
Yeah.
Prime numbers.
Prime number.
And Fibonacci sequences.
Right.
And specifically, we're going to be looking at A00057
Okay.
from the Online Encyclopedia of Integer Sequences, or OEIS.
That's right.
And this sequence focuses on those primes that divide all Fibonacci sequences.
Yes, and that's really what makes this sequence fascinating.
Yeah.
Is that it kind of brings these two like fundamental mathematical concepts together.
Mm-hmm.
But there's still a lot we don't know about it.
So much mystery.
Yeah, exactly.
So let's jump into it.
Sure.
So this sequence, A0000057, starts out with 2, 3, 7, 23, 43, and keeps going.
Okay.
And looking at these first few terms, is there anything that jumps out at you?
Well, I mean, they're all prime numbers,
Yeah,
right?
all right.
Prime numbers. So that's the first thing.
Okay.
But the real interesting thing is the rule that connects them.
Okay, what's that?
So it's all about divisibility.
Okay.
A prime number belongs to the sequence if the smallest Fibonacci number it divides occurs at the position prime plus 1 in the Fibonacci sequence.
So could you walk me through an example to make that a little bit more concrete?
Absolutely. So let's take the prime number 7.
Okay.
Okay, so if you look at the Fibonacci sequence, the 8th Fibonacci number is 13.
Okay.
And 13 is the first Fibonacci number that's divisible by 7.
Oh, okay.
So 7 is the prime.
Right.
And the position of that first divisible Fibonacci number is 8, which is 7 plus 1.
I see.
Exactly.
Okay, so that's pretty cool.
Yeah.
I think I'm starting to get it now.
Good.
So how does this specific sequence, A0000057, relate to other mathematical concepts?
Ah, that's a great question.
Because I noticed in the OEIS entry, they mentioned a connection to A0001602.
Right.
What is that?
Yeah, so A0001602 deals with something called the entry point of a Fibonacci sequence modulo, a prime. And what that basically means is it tells you the first position in a Fibonacci sequence where a number becomes divisible by that given prime. Okay. So the connection is this: a prime belongs to A0000057 if and only if its entry point in A0001602 is prime plus 1.
I see.
It's kind of a neat shortcut.
So if we can find out that entry point, then we can determine if it's in this sequence.
Exactly.
Okay, that's cool. But this brings us to, I think, the big question here.
Yeah.
Is A0000057 infinite, or does it eventually end?
Ooh.
Like, do we know?
That's the million-dollar question, right?
Yeah.
That's a question that's still open in mathematics.
Oh, wow.
We simply don't know yet. There has been research on the divisibility properties of Fibonacci sequences. Like, there's a paper by Kubre and Rouse that delves into this. But the question of infinitude is still a mystery.
So we still don't know.
Yeah.
Wow, that's fascinating. And speaking of mysteries, I noticed that the OEIS entry mentioned some interesting patterns within the sequence.
Yeah.
For instance, it said the first differences of the sequence for n greater than or equal to 2 are all congruent to 0 modulo 4.
Right.
Can you explain that?
Yeah, so basically what that means is when you subtract consecutive terms in the sequence, starting from the second term, the difference is always a multiple of 4.
Okay.
Which is basically another way of saying that each term is congruent to 3 modulo 4.
Yeah.
Meaning it leaves a remainder of 3 when you divide it by 4.
I see.
Yeah.
Okay, so they're all 3 more than a multiple of 4.
Exactly.
Interesting. But it looks like it gets even more specific than that, right?
Yeah, you're absolutely right. So for n greater than or equal to 2, each term in the sequence is actually congruent to either 3 or 7 modulo 20.
Okay.
And this pattern arises because of something called the Pisano period.
What's the Pisano period?
So the Pisano period basically describes the length of the repeating cycle when you look at Fibonacci numbers modulo a given integer.
Okay.
Yeah.
So the Pisano period is influencing these patterns that we're seeing in A0000057.
Exactly. It's another example of how, seemingly different areas of math can be interconnected.
That's so cool.
Yeah.
This is really fascinating. It feels like we're just scratching the surface of this sequence and all these connections to these other mathematical concepts.
Absolutely. Yeah, we are just scratching the surface.
Yeah.
There's a lot more to explore.
Okay, so I also noticed that the OEIS entry listed A0000057 as a subsequence of A064414.
Oh, right. Yeah. That's another interesting connection.
What is that?
So A0644414
Okay.
focuses on primes that divide at least one term in every Lucas sequence.
Okay, so what's a Lucas sequence?
So Lucas sequences are closely related to Fibonacci sequences,
Mm-hmm.
but they have different starting values.
Okay.
So instead of starting with 1 and 1,
Right.
a Lucas sequence might start with 2 and 1.
I see. Okay.
Or other starting values. But they follow the same kind of rule where each term is the sum of the two preceding ones.
Okay, so the fact that our sequence is a subsequence of that means every prime dividing all Fibonacci sequences also divides at least one term in every Lucas sequence.
Precisely.
Wow.
Yeah, it's a pretty cool connection.
Yeah, that's really cool.
Yeah.
Okay.
And there are even more connections in the OEIS entry.
Oh, there are?
Yeah.
What else is there?
Like, for instance, A079346 deals with primes dividing specific types of generalized Fibonacci sequences.
Oh.
And A106535 focuses on primes that meet certain conditions within Fibonacci sequences.
So I've got generalized Fibonacci sequences, we've got Lucas sequences.
Exactly.
This is really a whole network of interconnected concepts.
It really is, and that's one of the things that makes number theory so fascinating.
Yeah, but before we were talking about the question of whether A0000057 is infinite.
Right.
And I have to admit that question has been in the back of my mind this whole time.
Yeah.
Like, it's just really intriguing.
That's a captivating question for sure.
Yeah.
Even without a definitive answer, the exploration itself is incredibly valuable.
Right.
The process of searching for patterns,
Yeah.
forming conjectures, and rigorously testing them.
Yeah.
That's what drives mathematical discovery.
And even if we don't find that answer,
yeah,
just all these insights along the way can be just as valuable.
Absolutely.
Yeah. Okay. So I also noticed that the OEIS entry included a table.
Okay.
With the first 1,000 terms of A00057.
Yeah, that table's a great resource for researchers.
Yeah.
They can analyze the patterns, test conjectures, maybe even glean some insights into the infinitude of the sequence.
So beyond just like the theoretical side of things, we can actually look at this concrete data.
Exactly.
And try to figure stuff out.
Yeah, and speaking of tools, the OEIS entry also provides Mathematica and PARI code.
Wow.
For generating and analyzing the sequence.
So we can use computational tools to try to help us uncover insights about this.
Absolutely. Computational tools are becoming increasingly essential in number theory. Yeah.
And other fields of mathematics.
Okay.
They allow us to test conjectures, explore patterns, even discover new mathematical objects.
So we've gone from theoretical foundations to these practical tools for exploration.
It's a powerful combination.
Yeah.
The theoretical provides the framework.
Okay.
And the computational provides the means to push the boundaries of our understanding.
Wow. It sounds like we've only just begun our exploration of A0000057.
Indeed. And it's exciting to think about what other mysteries this sequence might hold.
Yeah, it really does feel like every time we peel back a layer, we just find more and more complexity to this sequence.
It's true. And that's really what makes this area of mathematics so compelling.
Yeah.
There's always more to discover.
Always more to discover, yeah. And speaking of discovering more, there was one more thing I wanted to touch on in the OEIS entry.
Okay.
Which is the cross-references.
Ah, yeah. The cross-references are like a roadmap.
Okay.
To all these other related sequences.
Right, that kind of tie everything together. Exactly. It shows how A0000057 connects to other areas of number theory.
Yeah, okay. So what are some of the highlights there?
Well, for example, there's a reference to A0001175, which highlights the role of the Pisano period. And then there's A001602, which we talked about earlier, that reminds us about the connection to entry points.
Yeah, and there are even references to sequences that we didn't talk about.
Exactly.
Like A00793646, which focuses on generalized Fibonacci sequences.
Right, and that just goes to show you how one OEIS entry can really open a door to this vast and interconnected world of mathematical concepts.
It really is amazing. Well, looking back, I think we've covered a lot of ground in our deep dive into A00000007.
We have.
We've explored its definition.
Yeah.
Uncovered some pretty fascinating patterns.
Absolutely.
And even talked about some of the open questions that surround it.
Still so much to explore.
Yeah. And we even saw how it connected to a bunch of other mathematical concepts like entry points and Pisano periods and generalized Fibonacci sequences.
It's amazing how interconnected everything is.
Yeah, and we even discussed how computational tools are being used to help us further our understanding.
It's a powerful combination of theory and computation.
Yeah. I think it's safe to say that our listener is now well equipped to continue exploring this fascinating area of number theory.
Absolutely.
So to our listener out there, I encourage you to check out the OEIS entry for 0000057 yourself.
Yeah.
Explore those cross-references.
See where it takes you.
And see where your own mathematical journey takes you.
You might even uncover a new pattern or make a groundbreaking discovery. Who knows?
And with that, we come to the end of our deep dive into the prime mysteries of Fibonacci sequences.
It's been a pleasure.
Thanks for joining us.
Yeah, thanks for having me.
Until next time, keep those minds curious